Monsoon really hits hard in some of the parts of India, especially Mumbai and West Bengal, and these are some of the news headlines we usually come across every year. Many metropolitan cities have adopted underground drainage systems, but manual monitoring is not so effective. That is why these problems are handled slowly. So, the city corporation should have some facilities. To allow maximum flow of clogged water, the manholes must be left open. For this project, the drainage system consists of gas sensor, water level sensors, and limit switches. So, the data from all these sensors is then processed by the Arduino board before being transferred to Raspberry Pi through serial communication. The information, such as the status of the manhole lids and water logging status, is then stored on a database using InfluxDB, and the outputs are observed on a user interface created using Node-RED.
Now let us take a look at the various software tools used in the project. Node-RED is a flow-based development tool used for visual programming and was developed by IBM. It is used for wiring together hardware devices, APIs, and online services as part of IoT. It is a web browser-based flow editor and can use JavaScript and Python functions. The application of Node-RED is deployed on Raspberry Pi, which acts as a main processing unit. The flow has been developed that collects data from sensors using Arduino and sends it over to Raspberry Pi for data processing. The user interface has various gauges that display sensor data and a map on the right that shows various locations of manholes and also gas sensor located in a given area. InfluxDB is an open source time series database and was written in Go. It is optimized for fast, high availability storage and retrieval of time series data in fields such as operation monitoring, application metrics, sensor data, etc. Here, the database collects data for each sensor separately. All this data is in the form of the measurements. We have generated a query to check on the sensor data from each measurement, and it can be observed. The time is also recorded for the data.
So this is the water level sensor that may be installed at a variety of locations throughout the region to monitor the level of water in various areas, inform authorities and residents of the situation, and provide immediate assistance in case of an emergency. So, when the water level rises in a certain region, which is depicted through these water-filled cups, the change in the water level will be detected by the water level sensors, and then this change would be getting displayed on the dashboard gauge. And when a predetermined threshold value of water level is achieved, the motor pumps installed in the system are triggered through relays to drain out the excess water and thereby prevent waterlogging in the area. Now, the major issue with the closed drainage system might be a rise in the concentration of hazardous gases such as hydrogen sulfide, methane, and so on. To detect the presence of such toxic gases, a variety of gas sensors could be put to use as shown over here. Now, the presence of these hazardous gases can be detected by installing gas sensors in the drains, and when the concentration of toxic gases accumulated inside the drains crosses a certain threshold level, the exhaust vents installed in the system will open to vent out the accumulated gas. So over here we can see that when the gas sensor detects the presence of some kind of smoke or hazardous gas, the Gauss length with the reading of the gas sensors changes, and when the concentration of the gas getting accumulated inside the drains exceeds a specific threshold, the drain's exhaust vents is open to vent out the excess amount of trapped gas and prevent the occurrence of any kind of accident.
Open manhole detection with LED signboard. The status of the manholes can be evaluated using limit switches positioned along the rim. The common terminal of the switch is connected to a positive voltage while the normally open terminal is connected to the ground. As a result, when the manhole lid is closed, the switch is pushed or is in the closed position, sending a high signal to the controller. We can determine if the manholes are open or closed by analyzing the signals received from the switches. However, in this project, we created a contact plate mechanism to demonstrate this feature. It is just a pair of conducting plates that are separated from one another. This mechanism is installed on the manhole rims and another conducting plate is installed on the manhole cover. When the manhole lid is closed, all the plates are shorted together, and when it is open, all of the plates are open circuited. The signal from these plates, just like in case of limit switches, can be analyzed to determine whether the manholes are closed or open. In this demonstration, the 4 plates represent 4 manholes. When the other plate is pressed to the plates, signaling that the manhole is closed, the LED signboard indicates the status of that specific manhole as closed by turning on a green LED, and a red LED indicates an open manhole. The status is also updated on the main server, which can be seen on the UI dashboard. The Python script for transmitting text messages runs with Node-RED on the Raspberry Pi. When the Raspberry Pi detects a change in particular parameters such as rising water level or gas accumulation, the script is called and an automatic text message is sent to people in the affected region. The script reads a CSV file containing the contact information of residents arranged by different regions. It utilizes the Fast2SMS gateway to deliver SMS messages to residents through an email address. The code may be followed step by step in the terminal window shown here.
For example, a city can be divided into smaller areas and data from each area can be stored in local database, which a mainframe computer can use to process and take decisions based on the data collected. This will reduce time in human resource allocation during demanding times.